Hello, meet again with Study with me. Today I have an opportunity to explain about the chemistry higher level paper 1 November last year 2023. I found that students find this paper quite hard, but I'm going to explain one by one, and if you find this is helpful, so please don't forget to subscribe my channel because I'm going also to explain other past year papers as well. So let's get started. Okay, for the question number 1, you just need to balance this equation by putting the right coefficient number so you can get the ratio between ammonia and oxygen, which is 4 for ammonia and 5 for oxygen and 4 for nitrogen monoxide and 6 for water, so you will get B. And for number 2, the reaction between metal M and sulfur producing MS2. To find the relative atomic mass of metal M, you need to write the chemical equation of this reaction first. Then don't forget to balance them, so you will get the correct ratio, mole ratio number. So the mass of sulfur is 16 and the mass of MS2 is 26 gram. So to find the molecular mass or the relative atomic mass of M, we need to know the molecular mass of MS2. So to find the molecular mass of MS2, we need to divide mole divided by N. So we don't know the mole of MS2 because we don't know the relative atomic mass of M, but we can do mole ratio through sulfur divided by 32.07 as it is the relative atomic mass of sulfur. Then you can get 0.499 mole. So to find the mole of MS2, it should be half of this because the coefficient of MS2 is 1. So mole of MS2 will be 0.249. You get it by dividing 0.499 divided by 2. So you can just plot the number. Mass is 26 and the mole is 0.249. So you will get molecular mass of MS2 is 104.41. Alright, so now we know the molecular mass of MS2 is 104.41, and we know that molecular mass or relative atomic mass of S2 is 32.07 times 2, so you can just eliminate them. So molar mass or the relative atomic mass of metal M will 104.41 minus 64.41, that would be 40. So the answer will be D. Okay, for number 3, there are 64 gram of methane and 96 gram of oxygen that reacted in a vessel. So what would be found in the reaction vessel at completion of the reaction? This is about the limiting reactant. So which compound that will be used up first, then what would be the excess reactant and the products that would be in the vessel. So I will write it back, the chemical equation of this, so you guys can see my calculation. So the mass of methane is 64 gram and oxygen is 96 gram. So to find the limiting reactant, you need to divide them with their molar mass, which is 16.04, and for the oxygen would be 32. So you will get the mole is 3.99 and this one will be 3 mole. Okay, so be careful with this because 3 mole is for 2 oxygen molecule, but 3.99 would be for 1 molecule of methane. Therefore, oxygen will be used up first or will be finished first or acting as a limiting reactant because for 1 mole of oxygen actually is 1.5 mole. Therefore, this will be reacted as limiting reactant. And this one, because the coefficient are not the same, so 1.5 times 3.99, you will get around 1.99. So 1.99 will be excess. So this will be in the vessel and this one will be in the vessel as well because these are the products. So the answer will be C. And for number four, you need to do a little bit calculation. So we have two isotopes, which is gallium 69 and gallium 71. So let me just make it like an example for gallium 69. Let's say this is X, and for gallium 71, this will be 100 minus X. So if we want to calculate the relative abundance for gallium 79, so let's plot them into a formula. So 69 times X plus 100 times 100 is 71 times 100 minus X divided by 100 equal to 69.72. So you guys will get 7,100 minus 6972 divided by 2 after doing some math calculation. So X will be 64. Like, you need to multiply this 69x plus 71 times 100 plus, minus 71x. So 69x minus 71x. So it will be negative 2x plus 7,100. And you will get this in the end. So X is 64. 100 minus X is 100 minus 64, which is 36%. So for gallium 71, 100 minus X, which is 36%. Alright, so for number 5, these are the ionization energies. So to know which one is X and which one is Y, we need to see which one that has high jump. So between the second and third, so we can check X, is it lithium or beryllium or carbon or helium, and Y respectively. So let's see the atomic mass of Li. So let's see the atomic number of lithium, which is 3, and for beryllium is 4, and for carbon is 6, and for helium is 2. So helium impossible because helium has only 2 protons. So for D, this is not the case. So we have lithium, beryllium, and carbon. So for lithium is 2 and 1. So 1 electron will be easy to remove, but for the second electrons we'll need higher ionization energy, and as you can see, it's not that really big difference between the first to the second. So we go to the beryllium, which is 2 and 2. So 2 electron will be easy to move, but not for the third electron. So you can see from the second to third, the jump, the difference is very high. So in this case, this will be beryllium. So the answer will be C. And what about carbon? Carbon is 2 and 4. You can see that 4 electrons will be easy to remove. There is no much difference between the second ionization energy and third ionization energy, as you can see here. So that's why the answer will be carbon. And for number 6, which one of the following observations provides evidence that matter is composed atom? So from the answer A, B, C, D, the answer will be D. As for the answer A is more about consisting proton or atomic structure or spectrum of energy. And then for B is to check the presence of ionic bond. And for C also to check the structure and bond. So the answer is D. And let's say for number 7. So number 7, let me just explain it a little bit detail. So the answer here is the transition metal, because they are their atomic radius is quite there's not much difference, that means similar compared to A, C, and D. So for A is lithium, beryllium, boron, and carbon. They are from period 2, and when you move across period, the atomic radius will decrease because of the nuclear charge increases. And then for C, they come from period 4, and you see that there is krypton here, and the atomic radius will be very small. So also the atomic radius decreases. And then for D, they are coming from the group. This is down a group, so the atomic radius increases. So that's why the answer is B. Okay, so now for number 8. So which aqueous solution would have a different wavelength of maximum absorbance from 0.10 mole decimeter cube FeSO4? So to check which one that has different wavelength, you just need to find out the oxidation number of this Fe. So this obviously will be Fe2 plus, because FeSO4. So if you make them into ions, so SO4 2 minus and then Fe2 plus. But for Fe2 SO4 3, so this belong to Fe, therefore this is Fe3 plus, and this one as well, so Fe3 plus. So the answer will be C. So Fe3 plus, this two Fe3 plus, they have the same wavelength of maximum absorbance except for the first one. And for 9, for which molecule can resonance structures be used to describe bonding? So as you guys know, HCN, they don't have resonance. It's only one type of Lewis structure. The same with H2CO3, carbonic acid. The same with PCl3, but not for sulfur dioxide, because the resonance will be like this. So SO2 has 2 resonances. The answer is D. And for number 10, which substance has high volatility in its pure state and high electrical conductivity in aqueous solution? The answer will be HCl. Why HCl is easier to evaporate compared to others. You know, NaCl is a solid, so it's not evaporate. It will not evaporate easily. And for the uh, chlorobenzene is moderately volatile. And what about HCN? So now we compare between HCl and HCN. So these two are very easy to evaporate, but there is a difference between these two. HCN has hydrogen bond, so um, the molecule or HCN is held tightly by hydrogen bonding, but not for HCl. So HCl will evaporate easier than HCN. And for number 11, which substance exhibits only London dispersion force between molecule? Okay, when we talk about London dispersion forces, we're talking about nonpolar molecule. Nonpolar molecule can be checked using the electronegativity, but you guys don't have a data booklet, so the only way to check whether these compounds are nonpolar is by checking their geometry. So that has the net dipole moment 0, so that would be nonpolar, which is PF5, because these are the structure of PF5. So the net dipole moment will be 0, they cancel out, so that's why the answer is a PF5, and this is non-polar molecule. And for number 12, which is the correct structure of SO3 based on the lowest formal charge, we will do a little bit of calculation here. So I will do a little bit detail of calculation here so you guys can see why the answer is D. So to calculate formal charge, as you guys know, is the number of valence electron minus, what I mean is valence electron here, so minus the number of half of bonding electron, and then minus the non-bonding number of non-bonding electron. Okay, so let's do for A. So we have two elements here. It will be sulfur and oxygen. So sulfur electron, valence electron is 6. So minus half times 6, because you know 1, 2, 3, 4, 5, 6, and minus there is non-bonding electron, so 0, that will be 3. And for oxygen here, the valence electron of oxygen is 6, also minus half, and for oxygen only 2 electron for bonding electron, so times 2 minus non-bonding electron are 6, so it will be 0. And for sulfur here, it will be 6 again, valence electron of sulfur, so minus half, so it has 1, 2, 3, 4, 5, 6, 7, 8, and there is no non-bonding electron, so 0, that will be 2, and there will be 2 for oxygen, so there is single bond, single, and then there is double bond. So for single bond, I can say that will be the same with this, okay, the calculation. So 6 minus half times 2 minus 6 and 0. And for double bond, you know, the valence electron of oxygen will be 6, and then half times for double bond 1, 2, 3, 4, so times 4 minus, there are 4 non-bonding electron, so that will be 0. And for C, FCS, so it will be 6 minus half So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10 minus, there's no non-bonding electron, again that would be 1, and for single O that will be the same, this way it will be 0, and for double bond, this is double, okay, actually also the same, so it will be 0, the same with this calculation. And for D, it will be 6 minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So half of 12, there is no non-bonding electron, which is 0. Then this will be 0. And for oxygen double bond, let me calculate. So 6 valence electron of O, and half of 1, 2, 3, 4. So times 4 minus, there are 4 non-bonding electron. So it will be 4 as well. So it will be 0. So this all 0. That's why the answer is D. What bond angle is most likely found with an sp2 hybridized carbon as the central atom? So sp2, the key here, the geometry will be 3 trigonal planar. So a trigonal planar, okay, trigonal planar has bond angle 120. Example, C, X, X, and X. Okay, so here is 120 degrees. All right, for the question number 14, which reaction release heat? Which reactions are exothermic? So for the reaction number 1 is a combination reaction. This definitely exothermic. And for the second one is adding the electron, definitely exothermic as well. And gas to liquid is a condensation, so releasing heat, and this one also exothermic. That's why the answer is D. And for number 15, it's about Hess law. So you just need to find out how you can get oxygen to ozone. So let me write it down again, the reaction. Okay, the key here, I want this and this. It means we need to eliminate this and this. I mean carbon dioxide and carbon monoxide. So because carbon dioxide here is 2, but carbon dioxide here is 3, so we need to make this 2CO2 becomes 3 by multiply 1.5. So let me write it back, the equation. That would be 3CO2 becoming 3CO and 1.5 O2. And for this one, will stay the same. All right, so now the number are the same, so we can eliminate them. So we'll get this one and this one. So that's why the answer is C. There is 1.5 times 566 plus 992. Okay, for question number 14, which reactions release heat? So which reactions are exothermic? So for the first reaction is a combination reaction. This for sure exothermic. And adding the electron, this also exothermic. And gas becoming liquid, condensation, also releasing heat. That means it's an exothermic reaction. So 1, 2, 3 are the reaction that release the heat. And for number 15, it's how do you calculate to obtain the conversion of oxygen to 1 mole of ozone. So let me write back the equation so you guys can see how the calculation is calculated. So 2CO plus O2 and 3CO plus O3, 3CO2. All right, so the number, we need ozone and oxygen. So we need to eliminate, or we need to remove carbon dioxide and carbon monoxide, but the number are not the same. So here is 2, but here is 3. So it means we need to make it to be 3, but multiply 1.5. But the other thing that you need to pay attention as well, the question is oxygen to ozone. So oxygen to ozone. So oxygen should be on the reactant, ozone should be on the product. It means we need to switch or flip this reaction. So I will flip the reaction. So oxygen plus 2CO producing CO2, but because it's already 1.5, multiple 1.5, so this become 3, and this become 3, and this become 1.5, and the plus 566 becomes negative 566. And for 3CO as well, because ozone producing 1 mole ozone, so I will flip this as well. So it will be 3CO2 producing 3CO and ozone. So now the number are similar, and this one also similar. So now we've got oxygen producing ozone. So negative 992 stayed the same. That's why the answer will be, 992 will become plus as well because I flipped them. So this will be 992. All right. Okay, so which expression represents the calculation of delta H? And as you guys know, this definitely, and this two definitely, and this 3 is not. So the answer will be A. Number 17. Which steps of this reaction have positive enthalpy changes? So the concept of atomization always endothermic, so it's positive. And for ionization, always endothermic as well, so this will be positive. But for hydration, sometimes positive and sometimes negative. When it is negative, if hydration energy is greater than lattice energy. When it is positive, if hydration energy is smaller than lattice energy. So this is not. The answer will be A. And for number 18, which combination of values of delta H and delta S belong to a reaction which is spontaneous? So spontaneous delta G should be negative. And you know this delta G, the formula, delta H T delta S. So if this one negative and this one negative, you guys will get this negative. That's why the answer will be A. Okay, for number 19, which statement describes a role that a catalyst might have increasing the rate of reaction by providing an alternative mechanisms? So there are two answers here, which is A and C, as increasing frequency of collisions between molecules will increase the rate of reaction, and they need to collide in correct orientation. So the answer, either A or C. And for the rate of the reaction of nitrogen oxide producing nitrogen dioxide and oxygen. So which expression would give the same numerical value for the rate? So to calculate the rate, it will be 1 negative 1 divided by the coefficient of reactant times delta concentration divided by delta T. So for the reactant here is N2O5. So the question will be negative half delta concentration of N2O5 divided by delta T. Alright, for question number 21, a proposed mechanisms for the decomposition of N2O5. These three reactions, you need to determine the rate determining step, which is slow. So the key to choose which graphic that is correct with the proposed mechanisms. So the first reaction as a rate determining step needs the activation energy more compared to the other two reactions. So if the activation energy of the first step is greater than the other two, so you definitely will choose B, because the first one is higher than the second and the third. The first one definitely no, because only two. And the third one, the activation energy is very low, so the reaction is fast. And then for D, the same. So the answer is B. Okay, so which factor is dependent on temperature, activation energy, or pre-exponential, or rate constant, or gas constant? So the answer is C. K is dependent on the temperature, because if the temperature increases, so does K. If the temperature decreases, so does K. So the answer of the question number 22 is C. Alright, for question number 23, what can increase the amount of CS2 present in the following system already at equilibrium? So, adding catalysts just to fasten the reaction and cooling the system is not gonna increase the amount. So, A and D are not the answer. So, adding some Cl2 to the system, if you add Cl2 to the system, the reaction will be reversed. So, the amount of CS2 will decrease. So, increasing the volume of the reaction is the right answer. Let me explain it a little bit why. So the key here is depending on the coefficient. Coefficient here is 1, and then this one is also 1, so it's 2. There are 2. And for this one, it's 4. Okay, so volume, adding the volume is the opposite with the pressure. So if you increase the volume, volume, you increase them, so the equilibrium will move towards higher number of molecule. Okay, so higher number of molecule here is on the right side. So increasing the volume will increase the amount of CS2, because on the product side the number of molecule or coefficient are 4, and this is the oppositely working for the pressure. And for number 24, to calculate the equilibrium constant Kc between this reaction, so you need to plot them into the formula, which is product, concentration of product to the power 3, because coefficient is 3, and B is only 1, divided by reactant. Okay, one thing that I want to point this for you, be careful if it is mole, but here is concentration, so you can just plot the number directly here. But if its mole is known and concentration, if mole is known and the volume is known, so you need to find the concentration first. So don't plot the number of mole directly because you will get the correct answer. That would be a tricky question. So it will be 2 to the power 3 minus 2, times 2 divided by 2 to the power 2. So that will be 4. The answer is C. Okay, sulfur dioxide emission from coal-fired power plants is a source of acid depositions, which are pre-combustion methods of reducing sulfur dioxide emissions. Alright, so this is the concept that you need to know. For the number 2 and number 3 are the pre-combustion methods, and for the first one is the post-combustion method. So the answer will be C. And what about the combination will make a buffer solution when 100 centimeter cube of each is mixed? The key here, if you want to make a buffer solution, so you need, it always contains an acid and a base. So between A, B, C, D, you will get C and D between acid and weak base. So the key point here that you need to pay attention is the amount of weak base should be bigger than acid, so that is the requirement to make a buffer solution. So the answer will be D. As C, they have the same concentration. And for number 27, it's very easy. You know, this is definitely not strong base, and this definitely is not strong acid. So the answer will be A. Why not strong base? Because the pH is very low compared to 14. I mean strong base. Why is not strong base? Because the pH definitely is not nearly to 14, and not strong acid because it's very far from the lowest pH, the low pH. So weak acid and weak base. And what is the pH of a 0.1 mole decimeter cube weak acid with Ka 1 times 10 to the power negative 5? So we calculate the amount of hydrogen ion, which is Ka times M. So you plot them, 10 to the power negative 5 times 10 to the power negative 1, because 0.1. So you get 6, negative 6. So you don't need calculator for that. It's just divided by 2. So this will be negative 3. So pH will be negative log 10 to the power negative 3. That would be this number itself, which is 3. So the answer will be 3. Alright, for the question number 29. So the acid H2S reacts with metal M, producing, okay, so H2S, you guys know H2S, so it will be H plus and then S2 minus, okay? So when it reacts with M as a metal, so M will react with S. So M S2 minus, so it will be M 2S plus hydrogen. Okay, so which combination shows the correct role of H2S and product form from the reaction? So we will compare H2S and then hydrogen as a free element here, so the oxidation number will be 0, and H2S, as we know, so H, it's positive 1 hydrogen, so it's gonna be reduction. So product from H2S reaction, which is hydrogen, so hydrogen between A and C, but it is reduction, So if it's reduction, it is an oxidizing agent. So the answer will be A. Okay, what is formed at the cathode in the electrolysis of 2 mole decimeter cube sodium chloride solution? In sodium chloride solution, so molten sodium chloride, we have NaCl and should be molten. So there is NaOH. Okay, for question number 30, what is formed at the cathode in the electrolysis of 2 mole decimeter cube sodium chloride solution? By default, actually NaCl. Okay, the electrolyte of NaCl will contain H plus, Cl minus, and also OH minus, and there is Na plus as well. Okay, Na plus and OH minus, they will remain in the solution forming NaOH. So now we have these two, H plus and Cl minus. So the answer will be hydrogen cathode. Okay, as you know, this one my way. So cathode will be negative. So positive will be anode, cathode will be negative. So if it's negative charge, so the positive ion will attract to the negative charge. So hydrogen is the positive, so that's why hydrogen would be at the cathode. Number 31. Which combination of atomic mass and charge on ion will result in the largest mass of metal M being electroplated by a fixed current for a fixed time? You need to know that metal ions with a lower charge will produce more metal than those with a higher charge. So, should be low, and larger atomic mass increases deposition rate. So, the answer will be B. Alright, what is the correct classification for the two compounds given? So this we have amine and alcohol. Okay, alcohol, so OH attached to the C, this one, that attached to 3C, 1, 2, 3. So definitely tertiary. Okay, so between B and D. But what about NH2? The concept for NH2 is not the same with alcohol. So NH2, to check whether it's primary or secondary or tertiary, okay, so NH2 it's primary, and then for the NHR will be secondary, and for NR2 will be tertiary. So NH2 is primary. So the answer will be D. Okay, for number 33, which is the first product of distillation from the reaction of propanol. Propanol, if we check the structure of propanol, will be primary. Okay, so this propanol is a primary alcohol. So primary alcohol, when is acidified with potassium dichromate, which is oxidation, will produce aldehyde. So aldehyde has functional group CHO. That's why the answer will be C. Which compounds react with HBr to produce 2-bromobutane? 2-bromobutane, when you just see these three reactions, you definitely know the reaction number 3 is not going to work because it's alkyne. So let's check for these two alkene. Okay, I will just make it into more clear structure. Okay, so these are two double bonds. So if I make it into one double bond, so we can add H here and we can add Br here. So 2-bromobutane. So the first one is correct and the third one is incorrect. So definitely 1 and 3 is not, and this definitely there are 3 is not, then definitely there are 3 is not. Okay, so without checking the second one, you already know the answer is A, but let me just make it to be, make or explain the second reaction. So CH3 as well. So CH and then CH and CH3. So this will be also single bond, and let's put H here and Br here. Even you put H here or Br here, still this will be 2-bromobutane. So that's why the reaction, the choice number 2 is also the answer. So that's why the answer is A. Okay, so for question number 35, which compound is likely to have the highest SN1 rate of reaction with OH minus ion? SN1 is tertiary halogenoalkanes. Tertiary. So tertiary, I directly see this as the answer. So CBr will connect to CH3, CH3, and CH3. So this is the tertiary halogenoalkane. And for number 36, so asking for what are the preferred IUPAC classification of this structure of 2.3 dichlorobutene, and Cl is on the same side, so it's this cheese. So and zusamin, yeah, I hope I pronounce it correctly. So cheese and also that, which is zig, which is together. So the answer will be B. Okay, which procedure is most likely to produce a systematic error? Okay, systematic error. They are including measuring volume of water from the top of the meniscus and or overshooting the volume of liquid or heat loss. These kind of examples of systematic error. So which procedure is most likely to produce a systematic error in determining meaning the original concentration of NaOH, and by titration with HCl? So you're not, by repeating is not producing systematic error, but when you titrate them 2 days after preparing, okay, so definitely some reaction or some HCl will evaporate and is not fresh enough. So if you titrate the sample 2 days after, you definitely will produce a systematic error in your experiment. So the answer will be D. And which graph shows the relationship between quantity of product formed and quantity of excess reactant after the limiting reactant is consumed? When the limiting reactant is consumed, the excess reactant is remaining in the mixture. So once there is no more reactant, as the limiting reactant is being consumed, it's complete, it's finished, so the reaction cannot be processed anymore. So excess just be there, the products just be there, and there's no more reaction. So it will be A. Which instrument can be used to distinguish between enantiomer? So it's C, polarimeter, because polarimeter can detect 1 or 2 enantiomers that are present in a sample. What about IR? IR is used to identify functional groups in molecules. for mass spectrometer is to identify unknown compound via molecular weight. And for NMR is to determine molecular identity and structure. Okay, for number 40, so you know this 3, so it's definitely CH3. And what about the answer is propane, because you see this, there are 3H and these are 5, so propane it's CH3. Okay, I will just make it to be like this. Okay, so C3, and then the other one is 5, so 5H. All right, so propanol, is with COH. So let me just make it to the structure so you guys can see it clearly. So for propanol, and then for propanone, and then for propanoic acid. So you've got here and you've got here, so 1H, but this one is 3. And here, okay, you've got 3, but the other one is 3 protons. And here you've got 1 and you get 5. So that's why propane makes more sense to be the answer for the question number 40. All right, so I finished explaining all the questions for the past papers November 2023. I hope this explanation helps you guys to prepare for the exam this year.